Good evening, everyone. This is the second session for the Tuesday sessions of the Fall 2020 Schulich Ignite program. Thank you all very much for joining us once again. I think our Saturday session went a lot better this week, so that was fantastic. But we are going to get started pretty much right away unless we have anything else we want to say. Anmol?
No, we're good to get started.
Fantastic. Then let's switch over to the presentation. We've had people dropping in, so probably not going to go too fast through the first bit, but we're going to do some review of what we talked about last week first. So the overall overview for this week is, like I said, we're going to do some review of what we talked about last week. We're going to talk about combining variables because we kind of touched on that, but last week we ended up being a bit rushed. So we'll go over combining variables more. We'll go over updating variables using themselves. We'll talk a bit about variable scope, which is a concept that can be a little bit tricky. So we'll try and make sure we have enough time to talk about that. And then at the end, we have some examples and some challenge problems for you all. So we're going to start with a review of how to get things working on the platform. And we are constantly improving the Spark library that we're using. So the command that's shown on screen, you'll need to run that once more or less every session, but only the once every session. You don't need to run it for every kind of drawing you want to make. So I'll show off that command, but I'm also just going to talk about the setup commands that we'll need to do. So these ones you will need to run every time you want to make a drawing. So in the first cell, you'll need to type import spark, followed by reload ext spark. And in the second cell, you need %% ignite. And then after that comes the code that you are actually doing. So we need to make sure that those are there in order for our code to work. So I'm going to switch us over to the coding window. I have left it at the same size as it was last week. I hope that that is all still okay for everybody. So I'm going to create a new notebook and select the Python 3 kernel. So in here, I'm going to enter the first command, the one that we only need to run once. So that's pip install -- upgrade Schulich -ignite. If I run this, it's going to make a lot of text. I've already run this today. I wanted to make sure that it worked. But when you run this, you will probably see all this text. It might update something, and then at the end it says you may need to restart the kernel. Don't worry about that. You can just hit this little the circular arrow there. The other command that we need is the one that we need to run every time we want to draw something. So we could put it after this, but I'm going to replace it because this is kind of ugly. We're going to type in import spark %reload extension spark, sorry, %reload ext spark, and we'll run that one. You can see it's finished running. And then in the second cell, we'll type %% ignite, and after that we need some code. So we'll type in here print hello world. And if we run this one, it should come up with done drawing and hello world. And again, if you have any issues with this, please do get in touch, especially with your mentors on Discord. They will be able to help you better than I will over the chat. Kieran has also shown given us a link to the code that you can just copy and paste in. Thank you very much for that, Kieran. So yeah, this is pretty much what we just showed, but this is what it should look like, right? Import spark, reload extension spark, then %% ignite, followed by your code. So one thing we didn't really talk about last week because it kind of was broken. As I mentioned, we are improving this week by week, so thank you all very much for your patience as we do that, is saving notebooks. So you can now save your notebooks as whatever you kind of want to name it, as you can see with these angle brackets here. So we have, I think, embedded in our slideshow a GIF, and we will see if that is actually visible. But the steps are to have the notebook that you want to save open. You want to go File, Save Notebook As, and then set the name as whatever you want. That looks like it will probably not be readable, so I'm going to switch over to the other window, and hopefully that will be better. So on this notebook that I made, I'm going to go File, Save Notebook As. It's popped up with a window. Let me hide this one. And I'm going to save this as session 2. And you can see it's now been saved up here as session2.ipynb. Switch us back to the presentation. If you have saved in a notebook, but you don't remember the file name, you can find that, but unfortunately at the moment it's a little bit complicated. So you will need to go to File, New, Terminal, type in ls, and it will show you all of your saved files. And then once you know the file name, you can go File, Open from Path, and enter the file name that you found. So again, I think we have a GIF demonstrating that, but it is again distressingly low res. So I'm going to once again hop over here. So File, New, Terminal. I'm going to type ls, and you can see it's popped up a list of all the files that I've made. So let's open my notebook from last week. I'm just going to copy and paste if I can. So File, Open from Path. I'm just going to paste that in. And we can see it's opened up my thing from last week, which doesn't have anything in it, but it sure is open. So you can access your saved notebooks that way. The last thing we want to talk about as far as notebooks go is how to download them. So say I'm really particularly attached to my session 2 notebook and I want to download it, or I want to submit it for Ignite points. The process for that will be open that particular notebook, click File, Download, and it should be automatically saved in your computer's download folder. Yeah, so I will again quickly demonstrate that just for clarity. I've got my session 2 notebook open. File, Download is right here. And it's opened up the download window. I don't actually want to download this, so I'm going to hit cancel, but you can hit save and it will save that notebook to your computer and you can then submit it. So that's the review of kind of the basics of how to use the platform. We're now going to talk about the actual stuff that we talked about. So last week we talked about a little bit of the kind of boilerplate, kind of the structure of how one of these drawings is going to look. And we talked a little bit about setup and draw, but again, we were kind of rushed, so I'm going to go over it in a little bit more detail than I might normally for a review. So when we write code that we want to run just the once, we will put that in setup, and setup will run through from top to bottom, and then we will leave setup. After that, draw will run over and over from top to bottom repeatedly until we tell the program to stop, either by hitting the button or through some other method. So it goes in a cycle forever. And we talked a bit about the variables mousex and mousey, which record the position of the mouse on your drawing. Those will only work inside draw. So you can't use those just in setup, because setup only runs once. It doesn't redraw the picture every time your mouse moves. If you want to have something that moves with your mouse, you need to make sure that you have draw so that you redraw it. I'll do another quick demonstration of that. So I'm going to make a new cell. Let's say def setup, say size 500, 500, and I'm going to try just using mouse X and mouse Y in here to draw a square. So I'll say square, mouse X, mouse Y, and we'll make it 100 units to a side. And what's that done? That's weird. Oh, haha. I forgot to put in the % ignite. So that's what will happen if you forget to put that in, is it will just probably not do anything. So if we run that now, you can see it runs and it draws, but it doesn't actually do anything, right? It just sits there. Nothing is drawn. So if we want it to actually change over time, then we will need to have a draw. So we'll say def draw, and we're going to say background. I'm going to make the background white. So you can see the square follows my mouse around. And if I hit stop, it stops and no longer follows. I hope that all makes sense. Again, we did kind of have to go through it faster than I would have liked last week, but I think a lot of you asked some good questions on the Discord, so hopefully you all have a good understanding of how that works. Another thing we talked about last week, and again, we sped through it a bit, is the arithmetic operators. Most of these are pretty straightforward. Addition, subtraction, multiplication, and division are all very straightforward. Modulus is a bit of a weird operator. It is like the remainder when you divide. So 5 modulo 2 is the remainder that you get when you divide 5 by 2, or 1. In the chat, Hamdan Mohammed Rafi has asked, can we change the color of the square that follows your mouse? Yes, you can. If we want to do that, I will switch this back over. We can say fill style, let's make it red. Yeah. So you can see it now draws in red. There's still a black border. If you want to change the color of the border, then you use stroke style. I'm going to make it purple. That should work. And it's probably not all that visible, but the outline is now in purple. Good question, thank you. Okay, combining variables. So we can give variables values, as we talked about last week. So here, this program that we have on screen sets up two variables, one named A and one named B. And it gives the value 20 to the variable A, and it gives the value 30 to the variable B. If we then ask our platform to print A plus B, it combines the values stored in A plus B and prints that result. So it'll print 50. If we ask it to print A times B, it will print the value stored in A times the value stored in B. And so that would be 20 times 30 is 600. Sorry, that 6,000 is one too many zeros. Then we can also give this new variable D a value that depends on the values of A and B. So in this case, we give it A plus B times 30. And A plus B, as we just saw, is 50. 50 times 30 is 1,500. So print D should print 1,500. Do you need to have the hash? So that is a comment. We talked about those as well last week. Those are things that you can include that won't actually do anything for the program. So I'm going to go to a new cell on my coding window, and I'll turn this back on. So in here, we say % ignite, we say A equals 20, B equals 30. I'm going to add a new comment just to kind of demonstrate. This is a comment and won't do anything. We're going to print A plus B, print A times B. Oops. And the next thing we had was D is equal to A plus B times 30. And this, then we will ask it to print D. And so if we run this, we see it prints 50, 600, 1500. Carter has asked, do you need % ignite in this cell? Technically, no, because this is all valid Python. That said, it's good practice while you're working with our platform to include the % ignite on all of your cells, because that way you won't forget about it. So say I decide to just put all of this in setup, and then make a whole program involving this stuff. I've already put it in, so I can't forget about this ignite, even though technically I don't need it here. But good question. Okay, we'll go back to the presentation. So quick question 1, answer in the chat. How could you use mouse X, arithmetic operators, and fill circle to make the size of the circle proportional to how far left or right the mouse is on the screen? There's a few answers coming in. So we have, yeah, I'm going to let somebody else check through those, I think. But Carter, your answer with mouse X, mouse Y, and mouse X times scale factor won't work because you don't actually tell it what scale factor, you don't actually set what scale factor is. Yeah. In any case, I will let somebody else go through those. One of our mentors can hopefully look through those in the chat and see if there's any answers in there. It looks like at least a couple people have come up with something very similar. But yeah, while that is being checked through, I'm going to continue on. So we're going to talk about updating a variable with itself. And this is this can read as a little bit confusing if you've only ever encountered the equal sign in math class. So here the equal sign doesn't mean that the two sides are the same. It's what's called the assignment operator. So the left-hand side is, if the left-hand side is a variable, then it's set to whatever the right-hand side is. And it will only ever work that way. It won't ever work the other way. So you'll never set the right side to be the left side. So in this case, we have height equals 170. So that is setting the variable height to have the value 170. The next line that we have there is height equals height plus 5. So what that means is that we want the value of height to be set to whatever the current value of height is plus 5. So in this case, that should print out 175. I'll again switch us over. So we say height equals 170. Height equals height plus 5. Print height. If we run that, we see it prints out 175. So even though we have height on both sides and it looks kind of like a broken equation, it does mean something, and it means something different from what it would mean in math. Here it's assigning the new value, which uses the old value. That was possibly phrased poorly, but if you have any questions, put them in the chat or ask your mentors on Discord. I'm now going to look through these answers again. Yeah, Mohamed has answered the quick question, so thank you, Mohamed. Okay, continuing on. So we have some shorthands for lazy programmers. So programmers are lazy. We would like to type as little as possible most of the time. So what we do for that is when we have something like height equals height plus 5, we don't want to type it out all the time, especially if it's a long variable name like height. That's a whole lot of typing. So we come up with these shorthands. So we have these symbols such as plus equals. So if we have x plus equals 5, that is the same thing as x equals x plus 5. if we had x minus equals 12, that is x equals x minus 12. So translating this one, we would have height, instead of saying it is just equal to height plus 5, the way we would write that is height plus equals 5, right? And this means the same thing as height equals height plus 5. As you can see, does exactly the same thing. Okay. Oops. Variable scope. So this is a little bit of a complicated concept, but we have a couple of things that we will hopefully be able to use to help you guys understand it. So variable scope defines how long a variable lasts for and what bits of code can see a given variable. So variables which started inside a function, such as setup or draw, don't exist outside of that function. And any variables outside of all functions are what are called global variables, and those need the global keyword. So we're going to talk a little bit about an analogy here. So we have, say, the United Nations. So that has some laws that it defines at the global scope. So, for example, human rights laws, such as no slavery. Right? That's a global scoped law, and that applies to all countries, and it can be seen by all countries, and it must be followed by all citizens of all countries. Then we have function scope. So Canada, the national laws have that you must be 18 to drink, but the US has that the national laws say you must be 21 to drink. So you only need to follow the laws of the country that you are in and the global scope and the global laws, right? So if we create a variable x inside setup, it only exists inside setup, very much like the laws being created in Canada or in the United States will only be seen in that particular country. It won't be seen at the global level. So if we then try to use x inside draw, we'll get an error because draw doesn't know what x is. It's never seen x before, it has never heard of x because x was defined in a different scope. So if we want to use the same variable in both setup and draw, then we would need to do something like this, where we create x as a global variable. Then inside draw, we tell draw that it should go looking for a global variable x. If we don't say that, it will assume that it should look for something local. And then after we've told draw to go looking at the global level, we can use x just like any other regular variable. So we can do x equals x plus 1, and that'll change the value of x. We can use x in our commands like circle, and that will all work just fine. So we have quick question 2. Is it okay to declare variables inside the draw function? Why or why not? And again, answer in the chat. It seems like some people have prepared answers in advance. But yeah, so the long and short of it is, technically you can, but it won't do anything useful. So what happens is when you run draw, when you write this program, it will set x to 10 the first time through draw. Then it will set x equals x plus 1, so x would be 11. And then we'll draw a circle with it. Then we go through draw again, so we draw our background, and then we set x to 10. We set x equal to x plus 1, so x is 11. Then we draw, then we draw our background, set x to 10, then x is x plus 1, etc. So the circle will only ever be drawn at x equals 11. But it's not broken. It's still fine. It just won't actually do anything. Which I believe some people answered. So yeah, good on you, those of you who recognized that. So we're now going to go to one of our exercises. So here we're drawing a diagonal sort of line using squares. Yeah, Lexi, congratulations, 10 points to you. So we're going to create a variable, use that variable to draw a square. Then we're going to change that variable and use it to draw some more squares. And using that, we're going to try to draw this pattern of squares going up and to the right. So Enmol, if you want to send us to breakout rooms, that would be fantastic. Okay, looks like we've got just about everybody back. I'm just going to quickly go over this exercise. I'm not going to do all of the steps to it, but I am going to just kind of walk through how I might approach doing this kind of this last thing here. So, switch over to that view. So because nothing's changing over time, I'm just going to use setup. So what I'm going to say is x equals, say, 10. Let's not miss the one button again. Very, very pixelated. Unfortunate. I hope that clears up shortly. If not, I may just turn off the presentation in the bottom right, because that's probably where most of the information is going. Let me know if it doesn't clear up in the next little bit. Thank you for pointing that out. So I'm also going to make y, and I'm going to set y equal to, say, 7. Because I already know that I want to draw something that goes up and to the right, and in order for something to move up, the y-coordinate needs to decrease. Because remember, the top left is 0, 0, and the bottom right is kind of our maximum on each of the x and y directions. So I'm going to say square at x, y, and with size 10. Say x plus equals 10, y minus equals 10. Square x, y, 10. And I can actually just copy and paste this whole block of text, right? Because I now just want to say increase x by 10 and decrease y by 10, and then draw a square. Do it again, for 6 times in total. If I draw this, you can hopefully see the squares going up and to the right. I'm just going to quickly turn this off so that hopefully we can get a little bit of a better view of the code that I've written. Very, very simple. Okay, again, let me know if it remains pixelated. I do apologize for that. I don't know what the issue is. We will continue on through the presentation. So we've used a variable to change itself, but we can also use variables to change other variables. And that's a very, very useful thing for us to do, because it lets us do stuff like have a speed of something which changes over time. And when we have this, we can do it just kind of as you see here. We have speed equals 3, x plus equals speed. And that will cause something that moves across the screen with the current speed, whatever that happens to be. And we can change that very, very easily. So I'm going to switch over again to here. Okay, resell. Setup, whoops. Say size 500, 500. We don't want to make our mistake from earlier where we define a function or a variable in draw and it doesn't actually change over time. So we're going to start by saying x is equal to 0 as a global variable. Now we're going to say def draw. Inside draw, we want to let draw know that it needs to go looking for x at the global level. We're going to have the variable speed. We'll say speed equals 3. We'll say x plus equals speed. Now we'll scroll a bit. Let's draw a circle at x and 100 and with a size of, say, 30. And, well, you can see it moving across. I forgot to put in a background. Let's do that very quickly. You can see the ball moving across the screen. And so we've now used the variable speed to change the value of the variable x. Let's stop that. We can use that in more interesting ways to have speeds which change over time. So, for example, something like gravity. I'm going to have sideways gravity because my screen is very sideways and not very vertical. But we're going to have a ball which falls kind of sideways. So we're again going to just switch back over to here. We now want our speed to change over time, so we want that to be global as well. So we're going to say speed equals 0. Here, instead of saying speed plus equals 3, we're going to say, speed, instead of saying speed equals 3, we're going to say speed plus equals 1. I'm also going to change the height of this to only be about 200, so that it will hopefully just be on screen by default. So if I run this, whoops, I forgot to add the global condition. So again, we need to tell draw where to go looking for the variable speed. So we'll say speed is also at the global level. And I think we've fallen off the screen already. So you can see it moves very, very quickly off the right edge of my screen. So that's how you can do something like gravity and have the speed change over time, as you can see there. So that's more or less all we have to talk about as far as new concepts today, but we do have some more features that we've added to the library since last week. So you can now write text using the functions text size and text. So the way that that will work is text size sets how big the text is. Then text takes 3 parameters. The first one is the text you want to draw. The second one is the text's x position, and the third one is the text's y position. Then another thing that we've added is draw line. So you can now draw lines. So you specify this with x1, x2, x1, y1, x2, y2. So you specify the x and y position of the one side, and then the x and y position of the other side. So let's quickly swap back over to the coding view. We will do text. We'll say size is, again, let's go 400, 200, just so it's all nice and visible on my screen. Let's say text size of 20. We'll write text. We'll just go with the same hello at 25 and 50. And then if we want to change our line style, we use the same function we used from earlier, which is stroke style. In that function, there's a few different ways you can do things. So you can either use the color strings, as we've been doing, so something like red, or you can use RGB color values. So 25500 means all of the red, but no green and no blue, and that will give us just red. I believe we talked about that last week as well, but again, we kind of had to rush through a lot of things. The other thing we added was the draw line, and so let's draw that from, say, x equals 25 and y equals 50 to x equals, let's go with 250, and we'll say y is still 50. So if we run that, we can see that we get text drawn at the x position 25, y position 50, where that corresponds to the top left corner. And then we draw a line from 25, 50 to 250, 50. And so that's how those work. So this isn't a quick question, so don't worry about it, but we want to know kind of how would you make the text move across your screen while also increasing its size. Kind of the way to do that is if we want something to change over time, then we need it to be global, and we need it to have something like a plus equals or minus equals. So if I switch back over to coding, we will leave, we'll leave all that in there. So say def setup, size, width of 500, height of 200. Then we will set up our global variables, which I always forget to do right up at the top. So we'll say x equals 0, y equals 0. We'll start with a size equal to, say, 10. Then we'll say def draw. We'll say text. Nope. We need to tell draw to go looking at the global scale for x, y, and size. So we say global x, y, size. Then we say text size of size. And we want to draw our text. Hello at position x, y. Then we want to say x plus equals 3. I'm going to make the numbers a bit smaller so that it all stays on the screen for a little bit longer. I'm going to make it x plus equals 1, y plus equals 1, size plus equals 2. So it's going to get bigger faster. So if we run that, oh, what have I done? Oh, right. So what I did there is I made the variable size, which is also a function. So when I made it a variable, that broke. So let's call this t size for text size. And one more time. You can see hello moving downward to the right and getting bigger. And if I had remembered to put the background in, that might look a bit better. There we go. Text moving downward to the right and getting bigger. So another thing that we kind of talked about is fading colors. So what would we do if we wanted to make a shape fade from one color to another over time? So below is one example. So you can use this code to make a circle become more green over time. So because we have 150, 150, that's actually going to start as kind of a purplish because it's red and blue. Then as we add more and more green, it'll move towards a gray color. Then as we keep going, it'll just become a light green. And so if I switch back over to coding one more time, once again, I still need to set up my global variables. So in this case, my global variable is green. So we say green starts at 0. Excuse me. Then we'll say fill style 150 green 150. After I tell it to go looking in the global scope for green, I'm very sorry everyone for continually forgetting that. So tell draw to go looking at the global scope for green, and then fill style 150 green 150. Draw a circle at 100 100 size 50, and then we will say green plus equals 1. So the green will increase over time. You can see we start out as purple, move to a gray, and it becomes more and more green. So here we have our second exercise for the evening. And for this one, you want to start by drawing a circle at the top left-hand corner of the window. Then you want to make the circle move diagonally down to the bottom right until it goes out of the window and disappears. And what you would also like to do as a kind of bonus challenge on this is make the circle gradually change from red to blue. So we can again go to our breakout rooms, Enmo, whenever you are ready. Okay, seems like we pretty much have everybody back now. So that's pretty much finished everything that we have for you guys this evening, aside from our kind of final examples. But we would also like to do a quick test of a feature on Zoom, the polls. We are considering moving to using that for the quick questions just because it makes everything a little bit more fair for all of you guys participating in the quick questions. So Enmal is going to send that over Zoom. So if you can answer that, that would be fantastic. And yeah, it should have popped up for everybody now. Brilliant. And yeah, we'll also just talk here about the exercises for this week. So the Bug Busters exercise, this is the stuff we're interested in having you guys do. So on the left, we have a ball effectively being thrown off the top of a cliff. And on the right, we have a ball which follows the mouse and these little rectangles which move outwards from it at a constant speed. So those are the exercises at the Bug Busters level. And at the Pythonic Lava level, we have another couple of exercises. The left one, I believe, is a ball on a spring, effectively. So just a ball on like an elastic. So see if you can figure out how to make that work. And the right one is a another kind of physics simulation, but instead of just doing gravity, we also have electric charge. So those of you who have done some of your physics should know that like charges repel. So here we have a ball that is both affected by gravity and negatively charged, falling towards a negatively charged surface. So as it falls, it then gets pushed back up. And then we have our just for fun exercises. On the left, we have a ball bouncing on a spring. And on the right, we have balls following the mouse in a kind of in a sequence, but you can see they're not kind of all just following in a straight line, which is what makes it so complicated. That one is quite complex, so if you attempt it, good luck. And well, how did our polling look? Did that look like it worked pretty well? Okay, fantastic. Yep. With that, we're going to go back into breakout rooms. You guys will have some time to talk to your mentors about any questions you have about today's session. You can work on the exercises and any of the prior stuff that you didn't finish. You can also work on that. So, Emma, back to breakout rooms when you are ready. Well, thank you all very much for joining us this evening. We really appreciate it. I hope you all learned something. I hope you all had a fun time. And yeah, if you have any questions, please do ask on Discord. Mentors, we will be doing our debrief session momentarily. But to all of our mentees, thank you very much for joining us once again. And we will see you next week. I don't think we have any other announcements this week, do we? Nope. Fantastic. Yep. Have a good evening, everyone.